Now it goes to the most important part of the snappyHexMesh dictionary, as it will directly relevant to how the meshes, so the background mesh we have built, and we want to carve out our air block and water block that's mainly defined in the snappyHexMesh dictionary. So I will build a blank file first, and then I will copy all this and explain it in the file of how it means. So bit by bit. So this one, this is the head file, and the three main operations of snappyHexMesh is called cancellate mesh, snap, and add layer. So mainly it's just refine our meshes around the edges of the background mesh and our STL file. And snap on means it will refine these meshes between the edge, and add layers means if we have some very refined boundary, we need to add layers on it. For example, some boundary layers in the free flow, we can put this on. And then the two main geometry we are going to export is here. So air block we have defined, and water block we have defined by using our CAD model and exported into the tri-surface, right? And this is a tri-surface mesh we define here. We can add extra name on it, which is air surface and water surface. That means all the surface of these blocks will have the name as you defined. So quite straightforward for this section. And next section, let's go to here. So as I said, there are three main functions with. So the second main function is to get the refinement of the edges. So the refinement edges means our STL file, how can we capture the surface or the geometric files that is interested. I will copy all this to the file. So this is the first step. So I will give annotation here. So this is step one. What we're going to do is refine the surfaces of the two meshes, of the two STL files. How can we do that? Because we have do a surface feature extract before, if you remember. If you want to refine of these surfaces, you can give it a level. So level 1 is just very minor refinement, and level 3 is very detailed refinement, because we are more interested in the air block, in the water block, sorry, that is more smaller region, so that we use the level 3. And for the air and water surfaces, we can add extra information on it, which means we can define a cell zone. So the cell zone air and cell zone water is exactly what we're going to use for the conjugate heat transfer. Remember, our cell zone is inside our surfaces, so that is our cell zone definition for the two surfaces. So at this moment, I don't need to refine any regions. So if I want to the regions to be refined outside any surfaces, I can use it. But now at this moment, I don't need. As the most important thing is here. So this is a critical part, which is the location in the mesh. So location in the mesh means because we have background mesh, right? And we have all STL files. So the snappyHexMesh lets you to decide which you are mostly interested. If you are interested in the outside, you can put the mesh point here. If you are interested in the STL file, you can put it here, because sometimes we just carve this out, right? And want to use the left region. But now what I'm interested is the STL file itself. So that's why I use the region inside the STL file. So, and how to do that? that is the most important part again. So you need to define the location in mesh. Location in mesh is exactly a point on the mesh that is inside your STL file. So we have added some pictures to show the STL file. If you are interested in this car, and we build background mesh, and in this castellated mesh control, we want to carve out this car out from background mesh, for example. So what we have to do is firstly just refine the edges, so the edges of the car. As we refine it, which means we add smaller cells around it, then we can easily to find the edges by cutting or remove the cells inside, because the surroundings already in small cells, so small features can be maintained. And also the background mesh will be also refined as well. Just make sure that all the cells to be removed exactly the shape of the car. So in our case, we want to remove the background mesh and maintain the car, right? So that is the car or the STL file, what we are mostly interested. So how can we do that? We just go to our parallel, and then I will find the tri-surface of the air block and water block, and I will just copy into or import them into the in the parallel, and I apply them, and you will see there's no any display of the STL file. That's because my background mesh, if you still remember, is bigger or it's bigger size than the mesh of the STL file, and that makes sure they cover all this, but also because this, we can't see clearly what is inside. How can we do that? We can change the opacity of this background mesh. So if I make a little bit transparent, I would say our air block and water block have been included in our background mesh, right? So I will use this, and then what I'm going to do in my file is the most important part, is try to find a mesh that is inside in our STL file. Our STL file has two, right? So the water and air block. I can use any of these two blocks, because when I refine the surface of these two STL files, I have built two cell zones for them. So cell zone air and cell zone water, which means I let the snappyHexMesh know I actually need both surfaces. So when I choose any location of this mesh, that will maintain all these two surfaces, or the two STL files, and even the background mesh that will be cut out. We will see it later. So the mesh I'm going to maintain is 0.05, so that is Z at 0, 0. So I can directly have a cart of this. So if I perform a cell zone cut, and I will check this, and what I'm going to maintain is mesh around here. So I know there will be meshes or the STL file around here. So the XY will be at the Y and Z 0, because they are symmetric. So they will be exactly, so Y and Z will be symmetric, so exactly in the center. That what I'm going to do is just make sure the X is in our region, right? So I will find some points which is mainly around here. So I can use this to make sure on. So that's 0, minus 0.05. And any kind of X and Y and Z will be in the 0. So that's how I find the location in the mesh. Address them again. So if I put them on, make sure I find the region that's exactly, so I can make this bit little transparent as well. So I make sure this will be in the Y and Z center, because my geometry is actually symmetric around the Y and Z axis, and I make sure X is exactly on the STL file, and that's what I'm going to do now to find the locations mesh. So there are another options of locations outside mesh, so this is optional, not necessary. I will just ignore this at this moment. And next I will go to the snap controls. So snap controls, you can say snap control is just make sure I have smoothed the edge of the STL file as background mesh, which means it will refine. So compared to here, it will refine the edges. Previous cutting, we leave some like sharp edges here, and then the snap will just make these sharp edges to be removed, and the smooth control. So I will copy this, and also I have add layers here to, if you want. So the add layers means you can add some extra layers around some interesting regions, which means the boundary or the fluid boundary. I currently have no such interest, so I just leave as empty. So I will just copy this and go to my dictionary, and I haven't named it yet, so I'll name it, and remember to save it as into the system folder as snappyHexMesh dict. Right? So that should be a very simple snappyHexMesh dictionary. I have no extra definition on it. Everything is so simple, so straightforward. And there are some levels, which means the air surface I will also have a level 1 refinement, and the water surface I also have a level 2, which means this one I'm more interested in it. And of course, most important part is the location in the mesh. So that's all the definition about the snappyHexMesh. And remember, always use the parallel to check exact mesh points located in your interested region. So I think I'm ready to run the snappyHexMesh at this stage. So we are nearly ready to run the snappyHexMesh, but before that, there are two preparations we need to do. So first, we'll copy the FV schemes and FV solutions into the system folder. So if you want to do that, you just go to our previous one. So my previous one is actually here. So I copy the system. I will give like any FV solutions or FV scheme. Just copy this and to my system folder. So actually these are quite the previous setting. I didn't change anything, so just make sure you have these two files in the system folder. That should be okay. And another thing is I just to build a zero folder. So why? Because when I build zero folder, the FV scheme will try to the OpenFOAM will try to build a new things into the system folder for our meshing. So I'll try to do that, and then I can run the snappyHexMesh now. So I will clear snappyHexMesh. So here there's an option called override. So if you choose to override, and the previous mesh will be paused, so it will be removed. The block mesh, if you still remember, will be removed. But if you keep this without override, it will have a new mesh in the new time. So we'll try to use here now, and then the snappyHexMesh is working for us. It may need some time depending on the complexity of your geometry, and you need to wait. Now I just need to pause my video, and when it comes to the end, I will let you know. So after running about I think about 2 minutes, I got the results, and it says finished, but I highlight here to always check the mesh with ParaView, and actually I did a minor modification on the mesh quality controls by the warning during the snappyHexMesh, because it said I should include these two parameters in the mesh quality control. Maybe because I didn't write any mesh quality control in my mesh quality dictionary, so that's why. So I add these two parameters here, and if you remember, I didn't run any override, so I didn't run override for the previous. So if I go back to my previous, I would say there are two polymesh that can be found. So the previous one, I think is because it have loop of the two iterations, and that's why it has the two different meshes. But if I load this mesh here, and I want to check if there's any change, so this is original one. So and then if I go to the next, I would say there will be some change, and I will just include it here again. So this is a new mesh, so it has the mesh 1, and because previously I have include previous one, so I just delete them, and I will open another one because I want to compare the meshes in different steps. That's why I use two different ones. So this I use the time 1, and this I use time 2. So time 2 for this one, and also I use the surface with edges. So there are maybe some iterations or overlap between them. So I might just to have a quick cutting on it on the very updated one, and if I hide, I will see some results here. So you will see the snappyHexMesh really work on it by refining the tube or the pipe sections, and also the sections around it, around the air region, but still maintain most of the background mesh. So we don't have any background mesh to be expected, but now all the background mesh still exist. So that's why in the further operations we need to do some operation by deleting the previous background mesh, but also split mesh regions and choose the mesh that we are interested.